In this video, we are going to discuss the problem called best time to buy and sell stock, that is number 121 on LeetCode. So the question goes as, you are given an array prices where price of I is the price of a given stock on the ith day. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. Okay, return the maximum profit you can achieve from this transaction, and if you cannot achieve any profit, return zero. All right. Let's look at the examples now. So the input is 715364 and the output is 5. Explanation: buy on day 2. The day 2 the price was 1 and sell on day 5. On day 5 the price was 6. So we can book a profit of 5, which is the maximum, right? On example 2, we have 76431. I can see that the stock is always falling and I cannot actually book a profit and I need to return 0 on this. All right. So let's go to notes and try and figure this out. So according to the question, we would be given an array which would contain numbers which signify the prices of a particular stock on that particular day, right? So if we look at the example there, the list was 715364. So let's just take the same list here, 715364. So to book some profit, what I basically know is that I can buy a stock at some less price and I can sell it when the price of the stock is at some higher rate, right? So in this case, if I buy at 7, I cannot actually sell it at any day where I can book a profit. But if I buy it at 1, I can sell it at 5 and I can book a profit of 4. I can book it, I can sell it when the price is 3 and I can book a profit of 2. I can also sell it at 6 and I can book a profit of 5, right? I can also sell it at 4, I can book a profit of 3, but the maximum that I can sell it for is with a profit of 5. But that's not it. I also need to decide at what point I have to buy the stock. There are chances that I could also buy the stock at 5 and then sell at 6, which would give me a profit of 1. I can also buy the stock at 3 and I can sell it at 6. I can get a profit of 3, right? So what we basically need to find is the best time to buy the stock and the best time to sell that stock so that I can have so that I can gain some maximum amount of profit. Okay. Uh, we also are specified that we can only make one transaction, right? So the chances are there could also be chances where 76543 2 that the stocks are always falling and I cannot actually buy the stock at any point to make some profit. In that case, I need to return 0. So what I can see in this problem is for every day, uh, I can actually look further and see what is the best amount of profit that I could gain if I had bought the stock on that particular day. So what I mean by this is, if I rewrite the list again, so I have 715364. So what I can do is I can go to each day and I can assume that I'm buying the stock at this place and I can check what's the maximum amount of profit that I could book. The maximum amount of profit where if I buy the stock at 7 is 0, right? I go ahead to 1 and I can check what's the max amount of profit that I can make if I had bought the stock when the price was 1, and that is 5. I can go ahead and I can check what's the max amount of profit that I can make. That's 1. Here it's 3. Here it's 0. And this is 0 as well, right? I cannot actually buy a stock on the last day to sell it. So, this approach tells me that if I go through the array and pick each element and I check for all the consecutive elements to check what is the amount of profit that I can make for that particular day, I can find the maximum. That is, I can start at the first element, I can find the max, I go ahead to the second, I find the max, I go to the third, I find the max, and so on, right? So this could be a working solution for it. But you can notice that I started off at zeroth index. I checked for all the elements there, and then I went to the first index and I checked the all the elements ahead of it. So if I have some n number of days, what I'm doing is I'm making the first time I'm making some n comparisons, and then I'm making n minus 1 comparisons, and then I'm making n minus 2 comparisons. This basically gives me an order of n squared time complexity, right? So we can solve this problem, but the time complexity for this solution is order of n squared. Can we improve this further? So while solving this, we noticed that we only care about the places where I'm making a profit. That means I'm buying the stock at some less amount and I'm selling it at the highest amount. So if I plot this on a graph, so what this will look like is 0th day my stock price is at 7, and then it's at 1, then it goes to 5, 1, 2, 3, 4, and 5, and it goes to 3, 6, and 4. So this is 3, this is 6, and this is 4. If I join the dots like this, right, so I can see that the stock graph looks something like this. From 7, the stock came down, it rised again, then it came down, and then another slope, and then finally it came down. So, what we really care about are these slopes, right? Where the stocks are actually increasing. These points in a stock is called a valley, and this is called a peak. This is the maximum that it booked, and then it fell. This also is another peak, and this is a valley. Since I only care about the maximum profit that I make, I don't really care about all the peaks and all the valleys. All I care about is the minimum valley and the maximum peak, such that the valley is before the peak, right? And this is the place where I should be buying the stock, and this is the place where I should be selling the stock to make the maximum amount of profit. And this was 1, and this is 6. And we know that the solution to the problem is actually 5. So what we can conclude from this is that we need to find the minimum valley and we need to find the maximum peak such that the valley should occur before the peak does, right? In that case, we can find the difference between this price and the peak price, and that is the maximum amount of profit that we can make. So when I say the valley should occur before uh, yeah, the valley should occur before the peak. What I mean by that is, let's consider a stock graph of something like this. So what happens here is this is the peak and this is the valley, right? I cannot actually buy a stock in the valley and sell it at the peak to make the profit because the peak occurred before the valley, correct? So what I can do for this thing is I can keep track of the minimum price and I can find the maximum price that occurs. So I can initialize my minimum price at here, right? And I can go ahead with the array, and whenever I find the current price to be less than min price, I can make min as the current. Yeah, min as current. Else, if I see that the price currently is greater than the min price that I have seen, what I can do is I can calculate the profit at that point. Profit equals current minus the min price. And if profit is greater than max profit, I can make max profit equals profit. right? So something like this will actually work. I also need to have something called max profit initialize, which would be at zero and a minimum would be at current, or maybe I can start at maximum value and then go ahead. So yeah, let's go over the lead code and try and write the code for this. That'll make things a lot clearer. So we are going to use Java for the solution here. So what I need to do is I initialize a variable called int min price equals integer dot max value and int max profit equals 0, right? Now I can run a loop through the array for int I equals 0, I less than, sorry, prices dot length I plus plus, yeah. So I have something called int car price equals prices of I, if car price is less than min price, which will be true in the first index because uh, any number that comes in the array will definitely be less than, the min price that I have initialized it at. Then I can make min price equals car price. Keyboard is behaving. Okay. And if it is not, I need to write the else for this. Okay, so what happens in else is I have something called profit equals car price minus min price if, okay, I don't need an if, max profit equals math dot max max profit and profit, right? So this should be working for me, and once I'm done running the loop, I can actually return max profit. And if I find nothing, my max profit is a 0, and that will return a 0. Cool. So that's it. Runtime 1 millisecond faster than 100% of Java time to buy stuff. Cool. Thank you.